Hello everybody. In this lesson, we will study about the fundamental theorem of arithmetic. But before we get into understanding this theorem, let us first try to grasp some of the basic concepts what we have studied in our lower grades, such as what are prime numbers. Now, prime numbers are those numbers that can be divided by 1 and the number itself. For example, let's take the number 2. What are the numbers that can divide 2, 1 and 2 itself? There is no other number that can divide 2. So 2 is a prime number. What about 3? What are the numbers that can divide 3, 1 and 3 itself? So 3 is a prime number. What about 5? Again, the numbers which divide 5 are 1 and 5 itself. So these and so on. For example, 7 is a prime number, 11 is a prime number, and so on. There are infinite number of prime numbers. So we know that a prime number is a number that can be divided by 1 and the number itself. But what about 4? What are the numbers that can divide 4? Let's list them down. 1, 2, and 4. That means there is another number other than 1 and 4 which can divide 4. So 4 is not a prime number. 4 is called the composite number. Similarly, let's take 8. The numbers that can divide 8 are 1, 2, 4, and 8. So since there are other numbers that can divide 8, so 8 is also a composite number. And there are infinite number of composite numbers. So now we understand what prime numbers are and what composite numbers are. Let's move on further. Let's look at the composite number 4. Can I write 4 as 2 times 2? 2 is a prime number. So 4 can be written as a product of 2 prime numbers. 2 times 2. Let's take the composite number 8. Can I write 8 as 2 times 4? In this, 2 is a prime number, but 4 is not. But can I write 4 as 2 times 2? So 2 is a prime number over here. So 8 can be written as a product of primes. 2 times 2 times 2. What about 18? 18 is a composite number. Can I write 18 as 2 times 9? And 2 is a prime number. And 9 is not a prime number. But can I write 9 as 3 times 3? And 3 is a prime number. So 18 can be written as a product of 2 times 3 times 3. So if you observe all these composite numbers and many such composite numbers, every composite number can be written as a product of primes. This is called the fundamental theorem of arithmetic. So this is called the fundamental theorem of arithmetic. Let us state this fundamental theorem of arithmetic like a mathematician in a formal way. So the fundamental theorem of arithmetic states every composite number can be expressed or factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. We will work out some problems on how to find out the prime factorization of a composite number. Let us see. Express each number as a product of its primes. For example, let's take 140. Now 140 is a composite number. Let us express 140 as a product of primes. 140 is 2 times 70 and 2 is a prime number. 70 is 2 times 35 and 2 again is a prime number. 35 is 5 times 7. So 5 is a prime number and 7 is a prime number. So 140 can be expressed as a product of primes, which is 2 times 2 times 5 times 7. Since 2 is repeated 2 times, we can express it as powers. The same thing can be written as 2 to the power 2 times 5 times 7. So we have expressed 140 as a product of prime numbers. This process is called prime factorization. Let's try another problem of prime factorization. $3,825. Let's do the prime factorization of this. 3,825 is 3 times 1,275 and 3 is a prime number. Now 1,275 can be further written as 3 times 425 and 3 is a prime number again. And 425 is 5 times 85 and 5 is a prime factor. And 85 is 5 times 17 and 5 is a prime factor and 17 is a prime factor. So 3,825 is a product of primes 3 times 3 times 5 times 5 times 17. So this can be written in terms of powers. Since there are 3 repeated twice, it's 3 to the power 2 times 5 to the power 2 times 17. So we have expressed 3,825 as a product of the powers of primes. This is called prime factorization of a composite number. Let's try a different type of a problem now. Find the LCM and HCF of 6 and 20 by the prime factorization method. Let's first list down the prime factors of 6 and 20. Then we will move on to finding the HCF and LCM. So what are the prime factors of 6? 2 times 3. 2 is a prime number and 3 is a prime number. So 6, the prime factors are 2 to the power 1 times 3 to the power 1. Now let's come to 20. What are the prime factors of 20? 2 times 10 is 20. 2 is a prime number. 10 can be written as 2 times 5. 2 is a prime number. 5 is a prime number. So the prime factors of 20 are 2 to the power 2 times 5. Now we can find out the HCF and LCM of 6 and 20 using these prime numbers. Now let's figure out what is the method of finding the HCF of 6 and 20. Let us see. In order to find the HCF of two numbers, what you will do is look for the common factors of these two numbers, the common prime factors of these two numbers. Now, what are the common prime factors of 6 and 20? It is 2 to the power 1 and 2 to the power 2. After figuring out the common prime factors, you pick up the prime factor with the smallest power, so which is 2 to the power 1. So the highest common factor of 6 and 20 is 2. Now let's figure out how to find the LCM of these two numbers, 6 and 20. What is the method? The method to find the LCM of two numbers is, after you have listed down all the prime factors, pick up all those prime factors with the highest power. We don't really have to look for the common ones. Now, in the 2's, the highest power of prime factor is 2 to the power 2. So we write that once. And we have another prime factor, 3 to the power 1. So we write that once. And we have 5 as one of the prime factors. So we are picking up the prime factors with the highest powers, and then we are multiplying them. So 2 squared is 4. 4 times 3 is 12. 12 times 5 is 60. So the LCM of 6 and 20 is 60. So we found out that the HCF of 6 and 20 is 2, and the LCM of 6 and 20 is 60. Let's look at this. Observe one thing. HCF of 6 and 20 is 2, and LCM of 6 and 20 is 60. The two numbers which were given to us were 6 and 20. Now, do you observe one thing? Whenever the HCF and LCM are multiplied, we get the product as equal to the product of the given two numbers. So 6 times 20 is 120, and the HCF is 2 and LCM is 60. Multiply them, you get 120. So we can generalize that HCF of any two numbers, A and B, times the LCM of those two numbers, A and B, will always be equal to the product of the two numbers, A times B. Now this is a formula to remember, and this works only for two numbers. It will not work for three numbers or more. Now let's try this problem. Find the HCF of 96 and 404 by the prime factorization method. Hence, find their LCM. So we already know by now how to use the prime factorization method to find the prime factors of 96 and 404. So let's just list them down directly. The prime factors of 96 are 2 to the power 5 times 3. If you do the prime factors individually, then you land up with 96 equal to 2 to the power 5 times 3. And the prime factorization of 404 will be 2 to the power 2 times 101. Now we know how to find the HCF of 96 and 404. How do we do that? Look for the common factors, common prime factors, 2 to the power 5 and 2 to the power 2. Among the common factors, choose the one with the smallest power. In this case, it is 2 to the power 2. So 2 to the power 2. So the highest common factor of 96 and 404 is 4. We found HCF. Now we need to find the LCM. But instead of using the prime factors, let us use the formula. Remember that HCF of two numbers A and B multiplied with LCM of A and B is equal to the product of A times B. We know this formula. So HCF of 96 and 404 is 4. We don't know what is the LCM of 96 and 404. And we can find the product of 96 times 404 easily. So now LCM of 96 and 404 is 96 times 404 divided by the HCF, which is 4. And if you do the calculation, the answer is going to be 9696. So the LCM of these two numbers using the formula is 9696. This is how we can use the formula to find either LCM or HCF of any two given numbers. Let's try this. Find the HCF and LCM of 6, 72 and 120 using the prime factorization method. Now remember, we can't use the formula of finding out the HCF and LCM of two numbers because we are finding here the HCF and LCM of three numbers. So let's just list the prime factors of each number. Remember the prime factorization tree? You can do that. So when we list them down, the prime factors of 6 are 2 times 3. And the prime factors of 72 are 2 to the power 3 and 3 to the power 2. The prime factors of 120 will be 2 to the power 3 times 3 times 5. Now let's figure out how to find the HCF of these three numbers. HCF of 6, 72 and 120. Remember the method of finding the HCF? Look for the common prime factors in all the three numbers. Now 2 is common to all. Pick up the smallest power of the common factor. So in this case, it is 2 to the power 1. Let us write it down. What else is common for all the three? If you observe, 3 is common to all. And we pick up the 3 with the smallest power, which in this case is 3 to the power 1. So we write it down once. 5 is not common to all. So we drop it. We don't pick it up. So then the HCF of these three numbers is nothing but 2 times 3, which is 6. Let's now figure out what is the LCM of these three numbers. LCM of 6, 72 and 120. Remember the method now? of finding the LCM of these three numbers? In LCM, you pick up the highest powers of all the factors, whether they are common or not. You pick up the greatest powers. Now in the 2's, 2 to the power 1, 2 to the power 3 and 2 to the power 3, the greatest power is 2 to the power 3. So pick that up and write it once. And for the prime number 3, the greatest power is 3 to the power 2. So we pick that up and write it over here. And in 5, we pick up, there's only one factor 5. So we pick that up and write it as 5 to the power 1. Now we find the product of this. 2 to the power 3 is 8 times 3 to the power 2 is 9 times 5. And you when you multiply all of that, you get 360. So the LCM of these three numbers is 360 and the HCF is 6. This is how you find the HCF and LCM of any three given numbers using prime factorization method. Let's try another type of a problem. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? In other words, they are telling us to find the LCM of 18 and 12. So time taken by Sonia to drive one round of the field is 18 minutes. Time taken by Ravi to arrive one round of the field is 12 minutes. So let's figure out what is the LCM of 18 and 20. LCM of 18 and 20. And by prime factorization, we know that the prime factors of 18 will be 2 times 3 to the power 2. And the prime factors of 20 will be 2 to the power 2 times 3 to the power 2. And we learned how to figure out the LCM. Look for the greatest powers of all the factors. So for 2, the greatest power is 2 to the power 2. So we list it down. And for 3, the greatest power is 3 to the power 2. And when you multiply them, 2 to the power 2 is 4 and 3 to the power 2 is 9. So 9 times 4, 36. So it will take 36 minutes for them to meet again at the starting point.